Good afternoon, everyone. Welcome. Holistic approach for a secure last line of defense. The topic cybersecurity is the topic of the day and of the week and of the year, obviously. So we are talking about security. We are a safety company, but for us, security has always been very natural because we take safety very seriously, and we've done that very long. And security is then a quite natural other side of the coin, so to say. There are two things that drive very much what we talk about. You all know about this, of course. Triton, just a few words on that. When we first heard about that, we were very shocked, of course, as everyone else, because I think for us it's like Stuxnet. It's the first time ever that the last line of defense has been compromised. We take this very, very seriously. We have initiated lots of activities, even though it didn't touch us. And we are, from what we know, quite certain that the same attack can't work anywhere else at the same time. So that doesn't mean we are safe or secure, but currently we are on the right side anyway. The other one is Meltdown and Spectre. Here we haven't heard so much from the automation side, actually. So the first thing I did was ask my people, hey, well, how does this affect us? And as a matter of fact, we have a lot of these chips in our products as well, because you can't come away from them. But since we do everything ourselves, we're actually not affected. So even though we use the same hardware, we are not affected by those attack possibilities because we do all the software ourselves. And as a matter of fact, we also do our own hardware. You can pass this around if you'd like. So we are not only producing chips, we are also putting our safety system on a chip. So what you have there is the smallest safety controller in the world, actually. So we use this in our products. That means we are even less dependent of publicly available chips. Security has always been an issue. And I'm not advocating to go back into the 70s, but in the 70s, security hasn't been an issue, of course, because it was virtually impossible to do any harm to those installations. Here is a system that we still sell. It's hardwired logic. It's fun as an engineer to see that. And they are actually still used. And I can tell you, the customers that are using those today and buying those today, they have been quite, I don't know the right word, happy when they heard about Triton, because they kind of felt extremely good at that time. That doesn't mean, I mean, of course you can change it with a side cutter or a soldering iron. But if you do, actually, the system shuts off immediately. So you can't just cut a cable here, that doesn't work. So if you do, it shuts down. So that system is actually secure. So we are still selling it, and there are only 2 companies in the world doing that, and we are one of them. But there are good reasons, of course, for programmable systems. So lots of effort has been done in the last decades, and we're doing programmable system today because we want flexibility, we want to change programs, we want to access it from outside, and so on. So there are many, many good reasons, of course, and the world is going here. But we have the cybersecurity issue, and we heard lots about that. So if it's a programmable system, we can't make it 100% tight, right? Because programming means we need to get there. And if we need to get there, someone else can get there. So what we want is, again, like in the 70s, 100% guarantee, but we won't get it. For safety, there is none. We know that. And this is exactly our business since 40 years. We know how to reduce the risk to a level that is tolerable. For security, we don't know the levels yet. But what we know for sure, there is no 100% guarantee. So every programmable system could be compromised, even though the effort might be very, very high. But we've seen it's obviously possible. So we call it the holistic approach. We've done a lot since many, many years because safety is in our genes. And we have done a lot specifically for security because we think it's important. Today, I think Marty Edwards said, it's not technology alone, it's a lot of other things. And of course, we know that, but we are a technology provider, so this is the end where we have to begin. When you look at safety systems and security, you need to consider different zones. And the heart of every safety system, obviously, is the sensor, the logic, and the actuator. This is what actually does the safety function. And if we have programmable systems, we have the holes into that wall that makes it accessible for the asset management station, for the HMI, or for the engineering stations. So we need to look at those interfaces here. That's the next zone. And this is basically what HIMA delivers. So we are only here. We are not anywhere else. And this is what makes us quite special, because we are independent from the rest of the automation system. And if you go to the control system, of course, you have another level. Why are those zones now important? You can say, hey, let's make the whole thing a high security zone. That is feasible. But this is incredibly expensive and uneconomical, because the rules that apply here, you would have to apply anywhere else. And this is not economical. So those zones are actually very well defined. And we need to be very clear what we have to require in which zone. And we need to do that properly. And especially the interfaces between the zones need to be looked at. Now, when we say holistic, we do many things, of course. And I want to go through very, very briefly what we do on the different levels. First of all is the controller hardware, like the chips and the electronics we do, and the firmware in it. Secondly, it's the engineering tool. That is the programming tool for the logic itself. We need the PC that the engineering tool is working on. That is something we have to consider. And the communication infrastructure, which is the pipes between all those zones, which is probably the most difficult part we have to do, or the most important part, because there's so many players in that part. And lastly, lifecycle management has two aspects. What do we do as a company to ensure security, and what kind of services are needed? And this is part of what we do and part of what the end users actually have to provide. For the controller hardware and software, and this is for me the most important point here. We are doing all of our software ourselves. We only do the logic, the safety controller. This is our only product. So we can concentrate 100% on that, and that means we do it 100%. And that is not self-evident. By writing our software ourselves, we make sure there are no libraries from other companies. There's nothing we haven't seen ourselves. There's nothing we haven't reviewed ourselves. So we are very certain that we know what we do. And we use the same software in all of our products. We do it very well, obviously. We spend 80% on testing, and we have lots of developers. So we can't afford not doing it. I don't want to go through all of this. One of the meta messages here is you need a lot of things to do. There are not 3 things you can do and you are secure. There's lots of activities, and these dots actually mean quite a lot. There's still a lot much more. Another important thing I want to mention is we have no backdoors. Our software realizes the functions we give it to them. We have no secret backdoors, and since we do it ourselves, we know there are no other backdoors, so nothing that can be exploited. And we are independent, so of course there's no common cause with the distributed control system, because it's a different software, different company, different philosophy. The engineering tool, again, we wrote it ourselves, 100%. I was in a conference last year and somebody said, oh, well, you can't write it all yourself. And I showed him and said, hey, yes, we do actually. And he couldn't believe it. He just wouldn't believe it. But it's actually true, and I think it's actually it's needed. Because if you don't have all the possibilities in your hand, how can you make sure that not someone else does something you don't want? It's a single-purpose engineering tool. We only do the engineering for the safety controller, nothing else. Something that is not talked about so much is not only the security against attacks, but also if something happens, how fast can you recover? We store everything in one data file, in one protected database that we can recover very, very quickly. Also, that is very important. Then, of course, we do all the things that are modern and that have to be used. It's not so difficult to know what to do. Difficult is actually to do it. We can block everything that is programmable. When the code is running, you can't change it. We usually monitor what's happening. That's a very simple one. We enforce password changes when we go on site. So there's no default password available anymore. Go and look in industry. This is probably 75% of all the installations. You still have the vendor's name as the password. It's so simple. So that's not much to do, but it has to be done, right? And I think there are many of these points that are, if you think about it, very simple, but they just have to be done. Functions can be blocked. locked function blocks. You can't either look at them or you can't change them. The PC infrastructure I don't want to talk about because everybody knows how to secure a Windows PC, but you have to do it. And we only use minimal functions of that PC. Only the services we need, only the programs that we need for engineering are installed. But that means that laptop is not supposed to be used for anything else. You virtually carry around your laptop around the firewall when you do things on the other side and on the safety side with the same laptop. This is bullshit because a firewall is supposed to stop something. But if you carry it around and you plug it into the system, there's no use in that firewall, right? Again, this is very simple, but it has to be done. Communication. There are lots of things in communication. This is probably the most techy thing you can do. There are lots of technological things you should do. What I'm going to talk more about is this one. And there's the saying that you can't bolt on security afterwards into a product, that you have to design it into it from the beginning. And actually, we've always done that. The hardwired system I showed you has a philosophy of, and I mean, it has to separate the control logic from the communication part, because there's a communication part even in the hardwired system. It couldn't even be connected, but we kept actually that philosophy in our programmable system. So it's a very, very nice separation between the CPU that does the logic and the communication. You can't get from one to the other. And I'll come back to that. And this, this you can't just change afterwards. Either you do it or you don't. And we've always done that. Separation of networks, that's very simple to understand, but very difficult to do. And I think if you look at industrial installations, the most problems you will find are on the network side, because it requires some kind of expertise which many companies don't have or don't want to use. Lastly, we as a company do what companies have to do today. We are certifying ourselves here. But we are certifying our products. And standards and certificates are good for proving that we have reached a certain level of requirements. So we are doing all this. And actually, I can tell very easily, we're not doing anything for it. We don't have any homework. We're just passing these tests. And this is why we're quite happy with it. We've always taken safety very, very seriously. And by that, we get a few things for free, or at least we have a bit of a tailwind when we go on the security side. So code reviews and all code analysis, this kind of stuff, is very, very natural for us. We've always done it. So we don't have to now do it just for security. Also something very, very simple. Nobody has access to this source code more than the developers. We are strictly decoupled from the rest of the company. So nobody can just take our code and do something to it. We are doing penetration testing. Even there, so far, we didn't have any problems. We are quite, we're happily doing it because we can only learn, but we are not even afraid of doing that. The last one is service. Service is something that we offer, of course, because we know our systems, but also the end users have to do it. And the most natural service is go and have a look at the installation in the plant and see, have you actually followed the cookbook? Is it installed as it was supposed to be installed? And this is by no means self-evident. And the next step would then, of course, be to look at the surroundings and say, hey, where are the weaknesses? You did everything right, but still there's a weakest link. In each chain, there's a weakest link, even if the weakness is still quite strong. But if you should do something, go for the weakest link until every link is so tight that you trust it. So remember that picture. Security goes in zones, and you have to know in which zone you are, which requirements there are, and how you actually do the interfaces between the zones. Now I come to the workshop that you can visit tomorrow. There actually we describe, and you will find again a lot of things I mentioned, how we build this inner zone, and basically actually two zones. So it's the blue square here. That's a picture you'll see tomorrow. I won't explain it here. The yellow is basically the blue zone on the previous slide. And we call it the HIMA security environment for functional safety. And that's not brand new, because it's a lot we've done all the time. We are just showing it in a comprehensive manner. And what I mentioned before, we separate the communication of the CPU properly from each other. We've done that since the 70s, and we've done it in all our products. Also the products, the programmable products developed in the 90s. Security was no issue there. But we've done it because it's our way of doing safety. So that's what I mean when I say we had a tailwind for security. So join it, my colleague Peter Sieber, who will do the workshop tomorrow, 12:15. You'll get to know everything about this HIMA environment. Oh, interesting. Go and listen. Next thing is we're also delivering presents, not to everyone, just to the lucky ones. So if you actually, we're a small company. Has everyone delivered his or her business card? If you don't do that, you will never have a chance to win, right? So maybe we do it in front. So one of you will go home with this local me. I hope you can use it. Try to... Good. Who is going to be the... Yeah, we have to separate the protection layers here, so I can't do it. It has to be someone else.
Dr. Montague.
So congratulations, then. Please come here. Come here. So there's another chance to win one tomorrow in the workshop. And if that doesn't work out, just visit our booth. So we brought 3 of them, as I said. Okay. So I'm finished here. Thank you very much. If there are questions, I'm happy to take them now or later, whatever. Yes?
I'm sorry to ask this prize, but
No connection.
one of the recent attacks tried in their meltdown Spectre, I forget which one, attacks the microprocessors in the kernel level. And since you're working at the logic solver level, I was wondering, are you affected by that at all? Is that,
The chip thing?
Yeah, the kernel-based attacks.
The attack is possible because the software running on that chip makes use of the specific hardware. Since we do the software ourselves, we are not even affected by that. We have always very strictly separated the parts of the chip from each other. It's a software thing. Right now, I mean, the fix is a software fix. But we never had that problem because we have our own operating system. So we were really happy when we realized that. So it's not even slower than before because we didn't even have to change anything. It's not like the PC. There's one exception. The engineering station PC, of course, that has to be changed as all the PCs in the world. So that we can't change. But for our own products, we are secure.
Thank you very much.
Thank you for listening.